adjust, right? So bring in and adjust. Put it somewhere around here. Click the adjust. What is the adjusted variable? The flow rate of the ethylene stream. So select variable. We want the ethylene stream. Mass. Let's see. We can adjust the molar flow rate since. No, let's put mass flow. We can do either. Let's do mass flow. What is the question? Okay, so we're going to be adjusting that. And click OK. And the target variable is going to be the flow rate coming out of a component. So we want the mass flow, component mass flow rate of VR1, component we can say mass of molar
Should
okay, mass
you sure?
of the
Should
dichloroethylene.
BR1. Yeah, I know, but like.
Click OK.
Oh, wait, hold on. You're going really fast.
Okay, let me go back and do it. Hold it.
Tim, that's 3 points. I get 2? Yes.
Okay, so this is where our product comes from. We want to specify the amount of dichloroethane we're going to make, right? Everybody clear? And in terms of amount, specify target value. Two options here. User supplied, and we give the value that we read from reactor 2. Reactor 1, we found that the amount of dichloroethane that we need is 115,625. Okay, 115,625 pounds per hour. So careful. No, kilograms per hour. 115,625 kilograms per hour. So we can specify ourselves that. I'm not sure. Oh no, because in one case we have component, in the other case we have the entire stream. If I can specify it from the stream, to be honest, I can quickly try it. It would certainly work if I put 115,625. Let's first put 115,625. So specify 115. Probably need to close it. Sorry guys, I need to deal with see what I'm doing here. So something open. So back to the adjust. Specify target 115,625. Okay, it wants a maximum. I was hoping it would work without a maximum. Okay, so ethylene and chlorine. Chlorine has more molecular weight than ethylene. Anyway, let's put maximum 100,000. So we go parameters. Let's put maximum 100,000.
Wait, hold on. Oh, how many many zeros is 100,000?
What's a minimum? Okay.
5.
Okay, minimum, I don't know. 20.
20,000 or?
Huh?
Oh.
Did I put too much? No.
Yeah, my thing went crazy.
That's it.
Dude, yours, mine broke. Mine's in red.
What are we setting the target value to?
115625.
I'll tell you what, let's do it smartly. Let me ignore the adjust. Let's first ignore the adjust. Let's use hand calculations to bring it close. And then use adjust to finish. Okay? So I'm going to ignore it, which is the same as removing it. Okay? So click ignore. And now I'll manually put the number. So let me try manually something like 20,000. Let's see how much we're making. And let's make a window so I don't have to pop let's make a table like we did before. So we want 115,625. Let's see what we have right now. So left clicking, right clicking, show table. Yeah, I'm way off.
Don't forget to save.
Yeah, what is it? I haven't done anything but saving it. But thank you. So, view properties. Let's delete everything that it has. Remove, 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 and then add variable mass flow.
Wait, are we doing this or are we just watching?
Yeah, you want to do that?
Oh shit.
Sure. Oh yeah, component mass flow. Thank you. Let's change it. Remove variable, add variable, component mass flow. And I need to expand it. Somehow it's not showing the number right.
I can't even grab it.
Trying to get the window to show the entire thing. Okay, I don't know what okay, here it is.
Oh.
All right. So, when I put 10,000, sorry, I'm getting 10,000 instead of 100,000. I need to be higher by an order of magnitude, right?
Wait, you're going really fast.
So that's what we are getting right now. With my initial guess, I'm getting 10,000, and we want
Does anyone let me set it?
here, and we want 115,000. Okay? When 115, we're getting 10. So we need to multiply by a factor of 10 simply, right? And then we can use the adjust. How are we doing in terms of being caught up? When is more time?
Yeah, you went really fast.
Well, again, this is not homework, but it's not something you're turning in. So you see, I'll manually change the variable until I get to the table. And then I can use the adjust to really get it.
You didn't change the variables after 200,000.
Yeah, I need to change that. Okay, so let me go back. And I'll go back to the assembly stream. So I had used 20,000, 200,000. It's mass. And now we're at 109,000, right?
Can you switch it over a little? Thank you. Yeah. Thanks.
Okay, 200,000 is what I put. All right? So, let's go back to the adjust now. Obviously, that's a problem. I put the maximum to 100,000. Is there any wonder it wasn't working? So let's make it 300,000.
I guess that's what he's doing now, right?
It's being ignored. So let's stop ignoring it. And lo and behold, there it goes.
Mine says
I wonder what.
I said it's a miracle.
It's a miracle.
What was the target value?
Well, the target value is 115, and if we check now, we make 115,625.
what's yours for?
So the ethylene that it's feeding right now is 210,904. That's what it calculated. So it corrected my 200,000 to 210,964. Okay? So this is the recommended procedure. Get some values to get it reasonably close. Then you can definitely put the maximum and the reasonable minimum. Don't do what I did before, which I went totally blindly. And I had the maximum that was too low.
Did you get it to work?
Yeah.
Okay?
Mine doesn't even let me do it.
So everybody clear on this?
You don't set it there.
Where do you set it?
And the adjust.
Yes, but again, combining
yeah.
adjust is not the best
You have to
thing.
adjust your maximum. It's way too low.
But
Oh, I missed a zero?
That needs to be 300,000, not 30,000.
So that's 5 zeros?
Yeah.
okay, let's go back and I'll put back 20,000.
Okay. Nice. Thanks.
Yep.
Not 2,000, 20,000. Okay. I could have taken this adjust. I don't know if it will work with different quantities. I could have made that adjusting molar flow instead of total flow that I did. But I can go to this adjust, and when you did the connections, we specify the given value. We can say another object and select the value of feed to a two.
What?
Okay? So I went in and it looks like it worked fine. Yeah, it worked fine. Yeah, it works. So Tim asked me, can you connect the two? And the answer is yes. That's the first thing that I did. Instead of setting user supplied another object, and I set the feed to a two. Okay, so you can see now the connection. The feed to a two is what gives to the adjust the value. It adjusts. We want to, here is the stream we want to change, and then here is what we are affecting. So you can see the arrows and you can see the two adjusts are interconnected. Okay? But
There's
again,
2 A's?
if you have one critical thing in your simulations, guys, when you simulate reactor, and later you're going to be doing recycle, it is important that you keep the stoichiometric ratio of the feed components that you have in your literature source. Your literature source says, for example, 5% excess chlorine, and your recycle is not at the 5% chlorine. You need to make corrections. So probably you need to add extra one stream or the other. So what comes in the reactor is 5% excess chlorine. So you need to make sure that what comes to the reactor is what the literature source has as stoichiometric ratios.
How did you
So you
connect?
need to use adjust for that. Okay? But if you keep the adjust active all the way, you now try to get the distillation column to converge. The adjust will make that so much harder. As a matter of fact, what I would recommend when you do distillation columns is to copy all the feed streams to the distillation column and take it aside and take it outside the rest of the simulation, converge the distillation column, and then change the simulation to follow the converged column.
How did you connect both A's?
By setting that the value, okay, let me do it again. First time I did it, I had chosen, let me make it larger. First value, first time I did it, I chose here, user supply, and I typed 115,625. Alternatively, it can be another object or something you have in the spreadsheet. In the spreadsheet. Here, put another object, and I specify the feed to the second reactor.
Got it.
Okay? All right. So you basically should now be able to do your deliverable 3 without hopefully any difficulty. The reactors is really something very easy. Okay, at least the chemical reactor. And remember, the bioethanol reactor is dry. Great if you do it, but you're not going to be penalized for not having done it.
Is Aspen going to be on the exam?
I'm not talking about Aspen.
Oh, sorry.
No, Aspen is not on the exam. As I said earlier, Aspen, I hope, will have at least 90% success in installing Aspen. But I don't expect 100% success in installing Aspen, so the exam will have 0 Aspen. But you will need Aspen for your project X. So each team needs to have several members that has Aspen
Boom.
installed. I would say the majority of the men should have Aspen installed. Most of your work will be in Unison, but something needs to be done in Aspen because something critical you cannot do with Unison. Okay, so let me bring up so glad I found this out. Okay guys, good job, man. I got to work for anything, so that's great. Okay. Good.
2018 is going to be a great year.
Hopefully it'll improve. All right. So we can save this if you want. What did I need? All right. And let me bring up the class website where I just posted the new homework assignment. So if we go to homework, we're going to see something interesting happening. Which is a totally failed Unison simulation limit. So go to Files, go to Homework, and let's bring up Homework 3.
No.
Yeah, that's too much of a math. All right. So this will be a liquid-liquid extraction exercise. We'll have a stream that has acetic acid and isopropyl ether, and this is going to be extracted using water, and we'll transfer the acetic acid from the ether stream to the water stream. And if we do it in a single equilibrium stage, Giacomo shows the calculation.